Good morning. For the next half an hour approximately, I'm going to be your host here. And today I'm going to be talking about multimedia analytics for business. The explanation comes shortly, what I mean by that. But first, a little bit about me. My name is Stevan, and I'm an associate professor. That's vanredni professor, probably in Ukrainian or something like that. And I'm by education a computer scientist. I got my PhD from Delft University of Technology in the Netherlands in 2013. I used to work at different places in the Netherlands prior to joining University of Amsterdam. I was a forensic researcher at the Netherlands Forensic Institute, that's Ministry of Security and Justice. I used to work at TU Delft, used to work at TU Eindhoven in robot vision. And by education, I'm also an electrical engineer. I finished electrical engineering at the University of Belgrade, where I also worked as a researcher. So I'm doing research in multimedia analytics, as the title of the presentation says, and I'm mostly focusing on business and urban computing applications. So what is this multimedia analytics? So multimedia analytics, how many of you are familiar with multimedia? What is multimedia? Okay, a few. So very simply, multimedia is a type of content that's composed of several different media, like image, video, text, information about users, and so on, you know. And you've been talking about heterogeneous data today, so basically, that's all multimedia. So what we do in multimedia analytics, we are combining the power of the machine of multimedia analysis to quickly process large amounts of data, to learn from it, and the capability of the human to quickly recognize patterns in the huge datasets. All of that with the goal of quickly exploring and searching large amounts of data. So I decided to focus on urban computing a little bit because that's something that we are finding increasingly important in Amsterdam as we try to help the city cope with multiple problems the city is facing with. So I'll start with some very simple applications and then gradually come to what we are doing now. So this is going to be also a little bit of retrospective. How many of you have been to Amsterdam? Awesome. So you, some of you multiple times, you probably noticed that it's super busy, you know, like, and Amsterdam is not the only city having that issue. Many other cities are having similar problems, Barcelona, Prague, Venice, and so on. And we are trying to help the cities by building these location recommender systems. So what happens is most people are just going to frequently visited places, while some places off the beaten track remain unnoticed. In 2014, we had this AC Multimedia Conference. That's the biggest multimedia conference in the world, the most important scientific event and for the practitioners. So IBM had a similar challenge. How can we actually show different sides of New York, given all this data on social media, different platforms? You have Facebook, you have Flickr, you have Picasa, but how can we let the people explore it actually more naturally? So with my PhD student, Jan Zachalka, also a Slavic person like me, only from Prague, and my colleague Marcel, who you may have seen last year here, director of our institute, we came with this New Yorker melange, interactive concept that allows people to find the venues through the eyes of like-minded users. So basically, we would be collecting large amounts of images, large amounts of text from different social media sites, modeling visual content, modeling text, modeling the metadata, and basically finding people that are similar to you and eventually recommending parts of the profile that may be interesting. With that one, actually, we won the Grand Challenge in 2014, and it was not about interface. That was not really important. What was important for us is to see that actually we can join such disjoint communities by doing this topical analysis in visual and text domain, and actually do interactive learning on a very large scale. Interactive learning, that means learning from the user very fast in a sub-second manner. Okay, so you're saying it's fine, you have a computer, you know, like, but I'm normally needing these kind of systems if I'm moving through the city. So the next thing was, I had a really great student at that time, Jorit. he hated Amsterdam. He lived in a small place next to the city, had a small family, 2 babies, like coming to the city was drama for him, He was like, okay, I would really like to take an alternative route, like to go where, well, less people go. And how do we help people do that? Well, maybe generating these summaries of the routes, like on the fly. So that's basically what we try to do here. It's also a lots of engineering challenge, like if you take a compass over time, even in the best phone, it wasn't working right in Amsterdam, like Amsterdam is very flat. We don't have high rises like here in the center, So you would point it certain direction, like, but a compass was going completely off. So we were generating these routes pretty much in a static manner, like in the nearby geographic cells. So again, how would we do this? Well, we would be downloading lots of content from social media portals, what people kind of find about the locations, how they talk about them, finding representative visual content and generating some small summaries, It's not as fancy as summaries you've seen in the next room, I think in a previous presentation. This is mostly kind of a tag cloud, But it was serving the purpose to give an impression about a location, hoping that people may take alternative route. Also, we had to think about routing, and this was another interesting thing, how to estimate actually crowdedness in a city. That's not easy, So we were thinking about the amount of content generated at a certain location as a proxy for crowdedness. So we would be incorporating that also in these kind of graphs, so that my student Jorit doesn't have to go with all of the other people in the same direction. Nice, but if I ask you, like to look at your iPhone and you got these moments, like these technologies are already coming to our phones, I was doing, for example, lots of summarization during my PhD. And yes, if I say the most representative image, it's fine. It's relevant for a given location. But maybe that's not the image that you would like to select as a human, and if you look at these moments on your iPhone, you're probably thinking, no, why did it include this one? And that's exactly what we started noticing, the big deal in these visual applications is, and make it or break it, is whether you selected the right images. And how to do that? Well, that's also something, this is a little bit of also older work. If you have a geographic area, what are the right images to select? So we would be asking a large amount of people using crowdsourcing. How many of you are familiar with crowdsourcing or Mechanical Turk, Amazon, and yep. So basically, we could give tasks to a large amount of people, hundreds of people, to make these visual summaries of geographic areas for us. And then what we would try to do is actually to learn to summarize those locations the way the humans would do. Very tough task, because we start thinking, you've probably heard about summarization in the next room. That's about a text. In visual domain, we have extra challenges, because images have also something that we call aesthetic appeal, Not all images are created equal. And also you have a sentiment associated with an image, what kind of sentiment it evokes in a person. So when we started generating these summaries and looking at human summaries, we figured out you have to incorporate all of this into your algorithm to be able to select the images the humans do. So exactly that's what we were doing. We would be taking the summaries, thinking about image content, context, aesthetic appeal, and so on, to learn how to select these images that people would be finding the most important, And what's very typical for visual content, I like visuals, you're going to notice in my presentation, it's all about images. When you try to summarize a news document, you look at the newspaper, it's probably going to be Trump this, Trump that, like Boris Johnson, Brexit, yeah. Most people are going to summarize it in a similar way. When it comes to images, well, people want that particular image, On average, they would agree in one or two images, two summaries. But there were some images that 11 out of 20 people would select always. So what are those images? So basically, this machine learning algorithms, and this is before deep learning time, learning to rank and so on, we would be trying to actually isolate those images in particular. Cool. So why are we doing this all? That's a good question. In Amsterdam, we find it really important. The concept that we find really important is city livability. And the government currently made it actually the key point of their 5-year program, improving livability of the neighborhoods and making sure that the people have equal opportunities. So Netherlands is very social state, like social system is very strong, but still some neighborhoods are doing good, some neighborhoods are doing bad, Some neighborhoods have lots of immigrants, and with immigration come maybe some issues. People are not feeling included, like how can we improve that? But to be able to kind of improve neighborhood, first we have to assess how well the neighborhood is doing. And that's basically what we are doing. So yearly, every municipality in the Netherlands is charged of evaluating something that we call social index and livability index. So what is a social index? Well, basically they would be asking people, like going from door to door, how do you feel? Do you like your neighbors? Do you trust your neighbors? Are the streets clean? Like and so on. Would you leave your keys at the neighbor? So as it happens, people are often not very inclined to respond, like honestly to those questions. I'm not advocating against questionnaires. Some of you are social scientists, and I believe that questionnaires are important, But city was wondering, can we do it in a little bit alternative way? So long story short, we started doing this sentiment analysis at the neighborhood level. So doing it from text, that's not very difficult. Many of you have already had some experience with sentiment analysis from text. But at the time when we started doing this was 2014-15, in computer vision, that's my community, we started increasingly estimating sentiment directly from the image. So basically, whenever you make an image, to some degree, it reflects either sentiment of the place or the sentiment that you are actually experiencing at the moment. And that's exactly what we tried to do. We analyzed this sentiment from the text, we analyzed it from the visual content, we combined it, and we tried to find some correlations with the factors that are related to livability. At that time, there were really funny articles in the Netherlands, like, money doesn't make you happy, like poor people are happier than rich, or immigrants are happier than the local people. And, it's nice to sell the news, but it didn't sound, like completely right. So basically, once we did this analysis, well, surprise, nothing super surprising. Higher income levels are associated with positive sentiment. The more people earn, more comfortable they feel, and basically they're experiencing higher sentiment levels. Also, people that live on a welfare checks, well, you cannot expect them to be super happy about their status, So this was some kind of pilot, but we learned that we can already use these technologies. This is around 2015 that I'm talking about, 16. And this is very funny. At that time, we started to learn in our community, look, we can actually estimate this sentiment directly from the image, We would be chasing something that we call this adjective-noun pairs. And this is a street my students hate, so in the morning you have to bike to the university. University is somewhere on the right side. It's a science park, our nerdy part, meaning social sciences are in the center, but labs and so on, it's on the right side of this. So I had a theory that this is a very depressive road, and look, machine also says, I don't like it, So, but Indian food is good, maybe not as good as Ukrainian, but, you get a point. Another thing, so back also in 2016-ish or so, we had lots of misinformation, call it, like fake news. We had lots of populist parties and so on, So entire Europe was a bit afraid, what's going to happen, So the city was thinking, the best way to fight it is actually to provide people with information. What kind of information? Well, information about what's going on in the neighborhoods. If you say, problem is this kind of people, well, let's see how many of these people live there, or imagine the other problem. City wanted to invest actually in certain projects and they didn't want to do it top down. They really wanted to ask people, where do you want it invested, And in order to decide as a community, I want to invest 10,000 in bicycle paths, they first have to see, do we need bicycle paths, And what did we do further with this one? Well, in Amsterdam, we have something also that we call community websites. So in Amsterdam, we have like 90 community websites. So we were building these small widgets. I don't know, you don't see my pointer well. It's here, this small thing. So basically, we would be building these widgets with such analysis, so that people can quickly look how their neighborhood is doing before voting on the projects that the city is going to invest in. A very, very nice thing. Again, something that we are doing with us. How am I doing with the time? I'm not sure. Is there some time? 5 minutes? 15 minutes. Sorry for this one. Good. So we are having lots of projects with the city of Amsterdam, and this is Martin. This is my PhD student. Very funny. He was my bachelor student, master student, and when he joined me as a master student, city had an issue. Issue was, in Amsterdam, we have something that we call a reporting system, it's not like Stasi or communism, like report on a neighbor. No, it's like reporting on the issues on the street, so for example, you see a garbage, you want it removed, you type a small text, through the website that city devoted for that, small app, or you put it on a social media with a special tag, and the city promises we are going to solve it within 3 days. Very ambitious goal. At that time, they had like yearly 50,000 complaints like that. And they asked me, can you help us somehow sort it automatically? I was like, sure. Martin is doing a master thesis, so let's try to do that. We thought it's a small project. It grew into a huge project, Martin is doing it now as a PhD, he's working 3 days for the city, doing 2 days PhD with me. And the other cities are actually copying it, New York City, Ghent, and so on. So what is it about? It's about designing intelligent citizen reporting system that uses this multimodal analysis of participatory data. So how does it look? It looks approximately like this. So last year, we had 173,000 complaints. It's growing. This year, we had 300,000. So better you get in sorting, then people complain more, It sounds like a paradox. Why would anybody complain if you get better? Well, they notice that it's going well, if it gets resolved, people think, it's getting resolved, so it makes some sense, so if I have an issue, I'm going to complain again. So you see, we are solving some problems and generating more complaints, and we like lots of complaints. So how does it go? If you have an issue on the street, in a public space, you would make some small report. So what gets recorded is a location. You can type a text. Just the boat is going too fast in a canal. Somebody dropped a bike, didn't remove it, or there is a garbage, dead animal, or something like that. What do you think is the most common complaint in Amsterdam? Anybody? There are rats, yes, in a pipe. That's this student area, with lots of cafes and so on. But not because of the students. There are buildings from particular time, and there is lots of wooden objects and so on. Rats, it's fun, but it's not the biggest, no. Yes, waste. So garbage is, you said waste. That's all. There are also bicycle-related complaints, but a garbage. I thought you said waste. Sorry. So the waste is the biggest garbage, basically, and we have lots of different types of garbage. So I think 60-70% complaints are about garbage, and we are not unique. We have a European project now. Most cities are having that as the single biggest issue: how to efficiently remove the waste and process it. So anyway, once you make this complaint, the point is, how do we actually get this classified? It looks like this, bicycle. It's there, and it's a fake complaint. We never show actual complaints, so this is just photo my student took, and we work with the actual complaints, but we never show them actually, yeah. So it looks something like this. Person takes a photo, writes some text. Somehow people assume that we know what the previous complaint was, but we never save identity. So it looks, oh, it's still there. It tells us person probably complained before, but we don't know about it, And we know location. We also know where we want to classify it. It should be bicycle wreckage. Because in Amsterdam, we have something like 70 different departments. So it has to go to correct department. If it goes to the wrong department, it's probably not going to get processed. And it's the same issue our colleagues in telecom companies have, people are complaining about internet connection and so on. If it gets to a wrong department, there is a delay, and sometimes it doesn't get even resolved. So this is basically what we collect. Then we extract lots of visual, textual features. We also analyze information from the GIS databases. What's, for example, in the neighborhood. So if there are cafes in the neighborhood, there is a higher likelihood that there are going to be complaints about the music, complaints about the garbage, and so on. So we incorporate it all into something that we call a multimodal fusion framework, how to fuse information from all these different streams. And on top of that, do some learning, either old-fashioned learning, or we do some kind of new fancy deep learning on graphs, to connect it all. To finally classify that information in correct category. And we are doing pretty well. Actually, we are almost as accurate as a human expert. And satisfaction levels, a human expert is still, I think, a few percent better, like 2%. But the satisfaction level is better with the automatic system. I think, I don't know the reasons, so I don't want to put any claims. We just published a paper in AC Multimedia, our biggest conference. I'm going to be presenting it next week. I think it's simply because it's faster. Like machine does it instantaneously, so the problem gets resolved faster. Although human is a little bit more accurate, I think people respect that it gets resolved faster. Okay, so this is something that we are doing now. This is a new project, basically, that we are running as a pilot. Martin keeps his Twitter feed up to date. So we are actually automatically detecting and counting garbage on the streets. So we want to detect how much garbage, how big is it, what's the volume, what's actually type of garbage, because we also have many companies collecting garbage. It's not one state company, it's like 7 or 8 in Amsterdam, So basically we want to know type, volume, material, is it organic, and so on. And especially here, when you have lots of it, well, sometimes they send a small truck. It's not sufficient, to collect it, so they call another truck. So you get even crowded streets, without reason, polluting a city and so on. So we are actually running pilots now. Can we do this automatically, actually? Okay. So where we are, I was adapting my presentation yesterday. Actually, one of these is from yesterday's news from Amsterdam. I think it's it's this one. So the mayor agreed on our next project. So basically what we are doing is we are hanging cameras on the garbage trucks, we are accounting all that garbage. We are also using these parking scanning cars. We are tilting cameras a little bit, to scan the garbage as they are checking the license plates for parking, And the idea is to send these electric trucks basically and without polluting much, collect all the garbage at once. That would be really cool. You don't have to send trucks all the way, but every day you know where the garbage is and you collect it all at once. So, how much time do I have? 10 minutes. Oh, very good. I'm doing good with the time, you see. So, it's a lot of data, and the issue becomes, how do you process it all in a real time? And if you've noticed, I work a lot with these interactive systems. For a citizen, like this category recommendation, you inserted something, you cannot wait like 3 minutes. Okay, when is it going to tell me what is, you want to see it now, or if you're searching something, like in a large collection of images, well, you want to get it in sub-second, time, like Google, you type in something, wait 3 minutes, we are going to get your result. No, it doesn't work. And basically, things get messy once you get such big collections of information. How do you do learning on the fly? Often, you cannot do deep learning because deep learning is data hungry, and you cannot ask a person, can you annotate 100 images and then we are going to tell you what it is about? Nope, that doesn't work also. So we were thinking, okay, my PhD student, I mentioned him, Czech, Jan Zachalka, he was saying, oh, we are awesome. I showed you that New Yorker melange. We were thinking, we went large scale, we had 1 million data points. I was like, well, if you think that we are so good, why don't you try it on the biggest one ever made, So this was the cover page of our communications of ACM. ACM is our mother organization. You heard about them. They are giving this Turing Prize. That's what we would call Nobel Prize for computer science. And this was a cover page some time ago. They released this data set with 100 million images, and they said, well, you want to claim that you are really big? Well, try this one. So really thinking, okay, this is a different kind of beast, you know. And if you start dealing with that kind of large collections and learning on the fly from the human in the loop, then you don't get only problems related to, I would say, learning algorithms. It's also simple things, you know, like write, read, you know, operations on a servers, you know, like supercomputers cannot crunch it easily, you know. So, but we are thinking, you know what? Why don't we try to bring it on a normal high-end PCs, you know? And to do that, well, we had to think about some compressed representations, you know, like how to compress the data better. And we also had to innovate in the learning phase, for example, make some classifiers that are able to function in such compressed domain. And that allowed us actually to do interactive learning on 100 million images, for example, in sub-second time. Still, we were using all cores of a such computer, you know, like, which is not very handy, you know, like if you want to also check your email or, I don't know, play something on YouTube. So then we start thinking, okay, and this is something that we are also going to be presenting next week at AC Multimedia, our biggest conference. We call it Exquisitor. We built it with Icelandic colleagues. They have a very efficient indexing scheme. Last year, one of their startups sold it to Facebook for 10 million or something for very quick matching of near duplicate videos. So thinking, why don't we join our Blackthorn model with this Icelandic ECP, and let's see if we can get even faster, actually. Try to bring it to laptops and maybe even mobile devices. So I'm not going to be showing this demo. It's a bit longish, but I guess presentations are going to be online. So I put it there just so you can actually play and see how it goes, you know, and how we can learn very fast on a, let's say, laptop on 100 million images. Cool. For the last 5 minutes, just about some additional work in progress. You know, it's not all about the scale when it comes to the size of the datasets. We are also having issues with modalities. So, for example, sometimes we want to model this ternary, quaternary relations. For example, if Indian person annotates this photo, Indian person is probably going to say Gate of India or Gateway of India, while it's Arc de Triomphe. So in order to understand what is it about, it's not sufficient to look only at the tags often, or to look at, for example, visual content. We have to get into analysis of joint analysis of social network or who the person is and so on. And to model such higher order relations, we actually had to solve some challenges that are currently even scientifically unresolved, as in completing these tensors that are associated with these higher order relations. So if you're a nerdy person like me and interested in that kind of stuff, I'm not going to go into details, you know, like you can check this paper. It's in a Brave New Ideas track of AC Multimedia for next week. So be free to just check it out. And something more interesting, that's I think one of the last things I'm going to show. We are really interested in assessing how livable such places are. For example, this is not Napoli, this is Amsterdam, and at some point we get this garbage all around. So how would we assess that these are the bad neighborhoods and, or not bad, but I would say not as well off as this neighborhood? Well, again, we are analyzing lots of images from the street panoramas. We are analyzing lots of GIS data, information about the objects in a scenery, trying to register those objects, trying to detect different issues, you know, like, so you see it's getting more and more kind of into computer vision, but in very practical use cases. And this is how we actually do it. We first do it often automatically, you know, like we make an automatic pass based on GIS databases or computer vision. And then we ask humans to correct it because, well, it costs less time than doing it from scratch by a human. If you're interested in these kind of things, well, you can ask Inske, my PhD student. You can write her an email, and she's going to be really happy to tell you all about it. And maybe in some of the next editions, well, she might join us here. We are doing this, by the way, with 9 different cities in a North Sea region, where Amsterdam is also belonging. And the last one, the very last one, I'm done within a minute. This is also about urban computing, but then a little bit of a marketing use case. So imagine that you are a company coming to Amsterdam or Kiev, and you want to know where to open the office. That's a typical problem. We call it store placement or so on. And the issue is also not only where should I open the store, but what is the visual look and feel going to look like? You want to open a restaurant, for example? Well, should it look like this or like that, and so on? So government is helping actually entrepreneurs, but they simply print you statistics, like, so many female or male people or people with this income live there. But people would like a little bit more insightful advice. So this is also something we are working on. We are trying to predict optimal location for a new retail business, for example. But not only that, give the advice on how it should look like to not only generate the profit, but also to improve the neighborhood. If there are many, for example, restaurants in a particular street, we kind of try to skew the model towards recommending a location that's also good for the business, but also more sustainable and helping the local community, for example. And about this one, well, you can write to Ujval. He's my also youngest PhD. He would be more than happy to answer all your nerdy AI questions, if any. And now some questions for me.
Because estimating sentiment from text is already a very biased task.
Yes.
Depending on the culture of the person, native language of the person, age, gender, sexuality, and all other traits.
Yes.
I guess, estimating sentiment from the image is even a more biased task. Like if you have a picture of an Indian restaurant, that can be a good thing for a person that likes Indian food, and it can be a bad thing for a person who thinks, these immigrants, they, cover the whole of the city and so on. So do you have any idea of the level of bias in this data?
It is really a big issue. Thank you for a great question, actually. What you see here, and what you absolutely correctly guessed, it's a very general sentiment analysis. And this is something that's vox populi, that means an average Twitter user. So who's using Twitter, and moreover, average English-speaking Twitter user, So there must be some bias, and huge bias, yeah. So how this was trained, actually, it's even more mysterious. These are one of the first implementations. This is 2013, first visual sentiment ontology. So basically, we would be analyzing text associated with images, estimating sentiment from the text, and then learning on the scores estimated from the text, assuming that they are more reliable, than a visual by itself would be. So this is not even generated by the human label, but this is really based on automatically generated, I would say, you would probably call it some weak supervision, a noisy signal coming from text. So you have some kind of noisy bias thing, and then you learn on that noise, So, right, there are lots of things to question there. But in the meanwhile, it's getting better and better. And also what was problem here is adjective noun pairs were annotated, I think, 1,400 of them. That's also not very large dictionary. So in the meanwhile, now we have these deep learning methods that go way broader, this pretty small vocabulary, Now it's getting larger, but still that bias is there, and it's not going anywhere,
I'm amazed by the efforts that you do to make Amsterdam better. And I must admit that I'm a bit jealous about it. So how can we bring the same to Kyiv? Do you collaborate with other cities to make it working like in Kyiv? Do you expect to?
We do that. We are always happy, through, for example, European projects. For example, let me show you. We are currently running a very big European project. It's called SCORE. It's focusing mostly on North Sea region because that's the program. Interreg, Europe has these financing mechanisms. And when you apply, for example, for Interreg project, it has to concern a certain region. But we definitely try to collaborate with as many cities. And here we intentionally didn't choose only cities that are doing well technologically, like Amsterdam, Hamburg, and Oslo is also with us. We also chose some smaller cities like Bradford, for example. It's smaller, they don't have a local university, so we're really wondering can we do something for a city that maybe doesn't have such knowledge base? Here in Kiev, I would say it wouldn't be that difficult because you have lots of tech people, I would say, great tech culture, local universities. I think it's a very fertile. So we can maybe think of a joint European project or something like that. I would be really curious how it scales also. I'm not sure, I didn't check it, but open data availability has to be kind of resolved. So in Amsterdam, that's pretty much not an issue. We have very good open data portals and even APIs that we can plug in, and get the data about neighborhoods. So I'm not sure anybody knows what's the status in Kiev, how much of these open data initiatives are there. But that's why it would be interesting, if everything was perfect, then scientifically it wouldn't be, thing. But we can talk about it, definitely.
So you mentioned that complaints about garbage, they're about 70-80% of all the complaints are actually about garbage.
I just said it roughly. I have to check in a database, but it's a huge amount, I would say.
But what about other issues? So maybe some potholes, maybe infrastructure?
No, garbage is absolutely the largest. I'm not just sure about percentage.
Well, yeah, but other?
What
about other issues?
Oh, yeah. Let me show you. I have here even the graph. So I'll try to read it. It's not super visible, but for example, here we have also size of the category. So some of the largest ones are bulky waste, for example, litter, waste and garbage. But you also have something like maintenance of the sidewalks and streets. So, for example, we have lots of these bricks in the streets, and they get out, so people complain, like somebody's tripping over, or children may kind of drop by. So that's a big one. Parking. So people cannot find parking, or somebody parked a car actually next to your window. That's also not nice. You don't see the sunlight, during the day. What do we have here? Unknowingly placed objects. So unknowingly placed object, that would be like that bike, It's not officially really like litter, but somebody tied it to, for example, object that belongs to your household, that's also not handy. Graffiti, that's also something we have. Loud boats, that's also an issue that's being addressed lately. New mayor is, for example, forbidding boat rides in some canals, because in Amsterdam we have lots of people living actually on the water. You've seen these houseboats and so on. And for those people, I have boat myself, and I have to admit that I'm also probably annoying some people with that diesel engine, so I have to switch to electric, but that's also a very typical complaint. I try to be very slow on canal, but if you're living in a boat, probably, any noise annoys,
You mentioned that the main goal of the program is to increase livability.
Yep.
And I wonder, do you have some key metrics that allow to assess livability, or you rather deal with tens of different metrics for each problem?
Yeah, we have actually a program in the country. We call it livability index and a social index, but each of them is made by many different matrices, like some of them very objective, like income level, number of people living on welfare checks, and so on, complaints of different sort. But also some of them are outdated. For example, it's a very funny one, sorry for my words, but they call it poop on the stoop, like dog litter, for example, on the streets. It used to be an issue in Amsterdam back in the days, but apparently it's not an issue anymore. People are more responsible with that regard. So also these indices have to be periodically updated. And what is annoying people, today maybe is not going to be tomorrow. So we are normally, as official index, you use official provided index of livability or social index. But true, I believe that they have to be updated. And that's also an open question. So we were thinking about, when talking about citizen reporting system like this one, that Martin is working on. Here you see some categories. It's like 57 or something like that. But they are thinking, well, how can you expand it organically? So that's a little bit of unsupervised learning, maybe, like data mining techniques and so on. but still consequences are large, should something be involved. So normally it comes from an expert, experts look at a collection. There is some new trending category. You're going to be laughed. What's the new trending? Roll coffer. We call it roll coffer. People are coming to the city. They have this kind of trolleys, and we have this bricks. So it makes tremendous noise, tuck, 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 tuck. So I was like, roll coffers. What is this? They're complaining about suitcases. So apparently they also influence livability, so I think we have to think of the air suitcase. That doesn't make the noise. I hope this answers, so it's constantly evolving, but currently we are using either these official complaints or official indices, livability and social index.
Question is about, do you have any issues with fakes? Maybe some group of prankers send you some fake images, fake news, fake complaints. Maybe you have to report it to police, something like this.
I'm not looking at, first to tell it, I'm not looking at the data myself. So I even do not want to look in the data myself. So it's my PhD student that mostly looks at it, but he's employee of the city also, why? Because of the privacy and ethical reasons, even in the beginning when we processed it at university side, we created a completely kind of safe pipeline, now municipality has their own secure environment, and so on. So it's there, first that one. And that's a good question, I have to say, because there are multiple ways of cheating the system. I wouldn't call it cheating. We have something that we call. Let me translate it from Dutch. Something like massive complainers. So there was a funny case. Some people are complaining about planes landing. It wouldn't be cheating. But there was a person that generated thousands of complaints per year, so apparently a person was sitting entire day and complaining about loud planes, So it would look like lots of citizens were complaining, but it was apparently same person. So how Amsterdam reacts, actually, they invited all these big complainers, they invited them to the data lab of the city and they really talked to them, hey, what's your issue? So what would you suggest? People are really happy, oh, wait a minute, these people care, about what I think. What can we do for you? Apparently something is pressing you really a lot, so he went, he saw how it's processed, So that's one way. But another way that I heard about, this is really funny. We have this official canal cruises in Amsterdam, and there are limited number of licenses for official canal cruises, for companies. So apparently they are issued based also on the number of complaints a different company got. So the companies were actually complaining about each other. So if I generate more complaints about my competitor, that would mean that they maybe lose the license and I get more licenses, So the student of mine, he's pretty skilled with those things, So we applied also some kind of techniques to check for that, timestamps, location, and so on. It's not police work. We are not kind of forensic scientists. I used to be, but we are not policing, but still, at least we give a signal to the, Martin gives a signal to a department that should check, guys, it seems that somebody was generating mass complaints about a company. Maybe it's just competition claim. But right, that happens, and these boats, I didn't see it coming, but that was the latest one I've heard about.